Hello, good morning, everybody.
Good morning.
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 Okay, thank you.
Morning.
Good morning. Okay, first I would like to be introduced with you. First of all, welcome to the Circuit Analysis 2 class. My name is Hassan Ali. Currently, I am the Associate Professor with the Electrical and Computer Engineering Department. Today, basically, I will be discussing about the syllabus and then subject matter of this course, grading policy, exam, class projects, etc. So before going that, I would like to be introduced with each of you one by one. I will be telling your name and then please you will turn on your video for the first time so that I can see your face. And you will be telling where are you from and are you from electrical or computer engineering or both? Okay, so with that first, Priscilla Amos.
Hello, I am Priscilla. I am here for electrical and computer engineering, and I'm also doing biomedical engineering.
Oh, you are biomedical. Okay.
Yes, sir.
Okay, thank you. Okay, next, Eric at this. Eric, are you there? Okay. Griffin Beard.
Here.
Yes.
Hi.
Yeah, so what's your department? Electrical, computer, or both?
Computer engineering.
Okay, great. And where are you from? Are you from Memphis or other city?
I am from Memphis.
Okay, thank you. Next, Michael. Michael Boyd. Okay. Roy Brookfield.
Yes, sir. You can call me Brad if you want to.
Okay, thank you.
I'm majoring in electrical and computer engineering, and I'm from Jackson, Tennessee.
Okay, thank you. Next, Mackenzie Brown. Mackenzie, are you there? Okay, no. Dylan Cothan.
Hi, I'm Dylan.
Okay.
I'm computer engineering.
Okay, computer. Where are you from? Memphis or?
Lexington, Tennessee. It's a little.
Okay, thank you.
Mhm.
Okay, Phaeton.
Can y'all hear me now?
Yes. So could you please
Major in
turn on your
computer
video
engineering.
so that I can see your face at least for the first time?
My computer doesn't have a webcam.
Okay.
On my desktop right now.
Okay.
I can get one by next class though if you want me to.
Okay, thank you. So what's your background? Electrical or computer?
Computer.
Okay. And where are you from?
I'm from Memphis.
Okay, thank you.
Mhm.
Next, CD Diao. CD.
Hello.
Okay. So can you please turn on your video? Is it possible? So that
I think it should not be possible right now.
Oh, okay. So are you computer or electrical?
I'm computer engineering major.
Okay, thank you. And where are you from? From Memphis or other city?
Yeah, I live in Memphis, but I'm originally from West Africa, Senegal.
Oh, okay. Thank you. Okay. Saad Elam. Saad
Can you hear me?
Elam.
Can you hear me?
Oh, okay.
Hey, yeah, born and raised in Memphis. I'm just going for electrical engineering.
Oh, electrical engineering. Okay. Thank you. Okay. Logan. Hello, Logan.
Hello. I'm going to be doing electrical engineering, and I'm originally from Parker, Colorado.
Okay, thank you. Okay, Danny Frazier. Danny.
Hey, I'm here. I'm from Memphis and I'm electrical engineering.
Okay, thank you. Aaron. Alums. Aaron.
Hi, can you see me?
Yeah, yes, I can see you.
Okay, yeah. I'm going for electrical engineering, and I'm originally from Horn Lake, Mississippi.
Okay, thank you. Asa Hanley.
All right. I'm also originally from Memphis, and I'm going for computer engineering.
Okay, thank you. Noah Hudson. Noah Hudson.
Yes. I'm going to school for electrical engineering, and I'm really from Brighton, Tennessee.
Okay, thank you. Then Ashley Jones. Ashley.
Yes, it's me. I'm from Memphis, Tennessee, and I'm in here for biomedical engineering.
Oh, okay, thank you. Roberto Martinez. Roberto Martinez.
Hey, I'm Roberto. I'm majoring in electrical engineering, and I'm also from Memphis.
Okay, thank you. Christopher McBride. Christopher.
Okay, I'm here.
Yes.
I'm studying electrical engineering, and I'm from Memphis, Tennessee.
Okay, thank you. Electrical, right? Yes. Okay. Saifal Modi.
Hi, I'm Shaival Modi. I'm majoring in computer engineering, and I live in Lexington, Tennessee, but originally I'm from India.
Okay, thank you. Computer, okay. Jeremy Porter. Jeremy Porter.
Yes, hi, I'm Jeremy Porter. I'm from Jackson, Tennessee, and I'm actually a biomedical major.
Oh, okay. Okay, Kyla Price. Kyla Price.
Hi, y'all. I'm Kayla Price. I'm computer engineering major, and I'm from a little bit outside of Nashville.
Okay, thank you. Okay, Muhammad Rajik. Rajik.
Hey, can you hear me?
Yeah, so could you turn on your video for the first time? Yeah, yes, now I can see you.
Okay. I'm computer engineering and I'm from Jackson, Tennessee.
Jackson, Tennessee. Okay, thank you. Okay, Emma Ronai. Emma, are you there? Okay. Khalib Thomas.
Yep, that would be me.
Okay. So are
I'm
you
here for computer engineering.
Electrical or computer, you said?
Computer engineering, and I'm born and raised in Memphis, Tennessee.
Okay, thank you. Next, Isaac Vasquez. Isaac. Hello, Isaac. Are you there? Jasri Walters.
Yep, I'm right here.
Okay, so are you electrical or computer?
I am computer engineering, and originally I'm from Miami, Florida.
Okay. Good. Next, Julian Wong. Julian Wong.
Can you hear me?
Yeah, yes. So are you electrical or computer?
I'm electrical engineering, born and raised in Memphis.
Okay, thank you. Zerick Wood. Zerick Wood.
I'm a computer engineer
Born in Memphis.
Okay, thank you. And then Faizan Zafar. Faizan.
Hey, I am born in Memphis and I am a computer engineer.
Okay, thank you. Okay, so Eric at this, are you there, Eric? Maybe no. Michael Boyd.
Yeah, I'm here.
Okay, so are you electrical or computer?
Say again.
Are you electrical engineering or computer?
Computer engineering.
Okay, thank you. Mackenzie Brown. Mackenzie.
I see them. They're down there, but I think their mic's not working.
Okay. So are you electrical or computer? Are you electrical or computer, Mackenzie? Yeah.
They're typing because their mic's not working.
Oh, okay. Okay. Thank you. Got it. Thank you. Okay. Isaac Vasquez. Okay. So fine. I think now you can turn off your video. You can turn off your video. Oh, Isaac mic not working. Okay, fine. Okay, electrical. Okay, so it looks like everybody is there. Okay, first of all, let me share my screen. Everybody, can you see my screen?
Yep.
Okay.
Yes.
Okay. So as you can see, once again, currently I'm the associate professor with the electrical and computer engineering department. So before going to the syllabus and other discussion about this course, first I would like to talk a little bit about me. Here you can see my academic background and work experience. So can you see like on the top, my degrees, and on the bottom portion, my teaching and research experiences. I was born and grew up in Bangladesh, and I took my bachelor degree from Rajshahi University of Engineering and Technology. It is called RUET. You can see on the top, third line. And then I started working as a part-time lecturer at the same institute, at the bottommost on, number 9. And then I became a regular lecturer, that is in 1996. And in 1998, as you can see, I got a scholarship from Japan government. So I had been in Japan in November 1998. And then I took my master's degree in March 2001 and PhD degree in March 2004. And the institute was Kitami Institute of Technology. It is located in Hokkaido Prefecture in Japan. And then again, I went back to Bangladesh and promoted to assistant professor, but I continued only 3 months, like September to November 2004. And then again, I went to Japan, like number 6. I got JSP's postdoc fellowship. It is called Japan Society for the Promotion of Science. And that was for 2 years. So from November 2004 to January 2007. And then I went to South Korea, Changwon National University, like number 5, to work as a research professor. And I was there from February 2007 to December 2007, just about 10 months. And then I moved to Canada, Toronto, Ryerson University. as a postdoc research fellow. And I was there 1 year and 6 months, January 2008 to June 2009. And then finally I moved to USA in University of South Carolina, Columbia, and then that is as a faculty. But that job was temporary in nature. So again, I started looking for regular permanent position. Finally, I have been at the University of Memphis in fall 2011, and I promoted to associate professor. My job got tenure in August 2017. So here is my brief academic background and work experience. And since joining this university, I established the Electric Power and Energy Systems Laboratory. So the room number is ES211. And here is my lab website. If you just Google this on, or if you just Google the name of the lab, like Electric Power and Energy Systems, then it will take you there and you can see detailed information. Currently, I have 5 PhD students who are working under my supervision and 2 master's students. And so far, I graduated 6 PhD and 12 master's students. And they are working in various industries and they have been faculty at universities. Regarding more research, you know that the major keyword in my research is electric power or energy system. And then a specific topic are photovoltaic or solar power, wind turbine generator, energy storage, smart grid or microgrid, and cyber security in power grid. Okay, and then we do research and I do teaching. And what is my accomplishment? So we always evaluate the accomplishment of my research and teaching in terms of publication. So as you know, my research area is electric power and energy system. So far I have total publication 190. Like I have 2 books about wind energy systems. I have 4 book chapters, 2 patents, 7 innovation disclosure. I have published 59 journal papers, and I attended or presented papers in 96 international conference paper and 20 national conference paper. So international conference means the people from all over the world can participate in that conference. And national conference means it is specific to a country. For example, a conference may be held only in USA or only in Canada or only in any country. And always we evaluate these accomplishments in terms of citations. Like, so as of this morning, so if you Google my name, then it will take you to the citations. This is 3,900. This means that these my publications 190 citation means how other people are using or referring my works in their research work. And then among the citations, there are 2 factors. One is called H index, other factor is called I10 index. So H index 32 means among these 190 publication, at least 32 works have been cited by other researchers at least 32 times. Similarly, I10 index means among these total publications, at least 79 works have been cited by other researchers at least 10 times. So that is, so you need not to be bothered or worried about these things. These are just the indications. Okay, so moving forward. So here is the course information. So I think as I sent you an email that I already uploaded the syllabus and the course information a few days back. And yesterday I uploaded the class projects. So has anybody seen that I uploaded the class projects? Have you seen?
Yes.
Oh, okay. Today I will be discussing this one about that. So you need not to be worried. So everything will be fine. First of all, prerequisite for this course. So you all know well, there are 4 courses, I think 2201, that is your circuit 1, then 2207, math 2120 or math 3402, and then physics 2120. And this is the suggested text, William Hyde's 9th edition. But I would recommend you to mainly follow my class lectures and the material that I upload. That will be fine. And then meeting time and location. So you all know that Monday, Wednesday, and Friday from 9:10 to 10:05 a.m. And I have put the location here, 218 Engineering Science Building. This means that if we go for on-ground class, if the university decides, then this will be the location. So we will talk about that later. So at this point, you are fine. Here you see that I have posted my office hours. Actually, these office hours when we all are on ground, on campus. But anytime, if you have any questions, comments, anything you need, you can just email me. As I said, by appointment, this means for you, a specific case, I can arrange a specific Zoom meeting. But if you just email me, then I could answer you. Okay. Now, here is the course objective. So you all have studied circuit 1. So circuit 1 means basically that is the DC circuit. But in this case, circuit analysis 2, this is the AC circuit. So you will be learning that AC circuit, and you will be learning much more transient analysis and concept of frequency characteristics. When you all studied DC circuits, then you were not worried at all about the frequency. But in this course, you have to learn the frequency. The frequency has a great role in control, communications, filter circuits, in any application. And then magnetic circuits. So I will be talking in a minute. And then sinusoidal steady state, power computation, and two-port network, like the transformer. So these are basically the course objective. And then moving forward. So now everybody see this one. This is the course preview. We will start from chapter 9 of the book. And then we will be covering all the way, I think, last on the chapter, actually Fourier circuit analysis. This will be chapter 17. Polyphase circuits, the last on, this is placed much more early, I think chapter 13, but we will go in that sequence. Anyway, so as you can see, the first on RLC means resistance, inductance, and capacitance. So you all remember that you studied basically 2 things, RL and RC circuits, right? Can you remember? You studied RL and RC. They are transients, probably chapter 6 and 7 from the book. But in this course, first you will be learning RLC. This means the circuit that includes resistance, inductance, and capacitance. So, and once resistance, capacitance, inductance are involved, then it is not the simple differential equation. It is the second order differential equation. That's why it is called second order circuit. Basically, we will be looking the transient. How does the circuit behave due to some sort of excitation? And then the second bullet, sinusoidal steady state analysis. This is basically the actually AC circuit, and the waveform should be the sinusoidal. Accordingly, it is called sinusoidal analysis. And steady state means we will not consider any transient, just simple AC circuit. And then third topic will be AC circuit power analysis. Now, everybody, you remember that in case of DC circuits, you just studied its power, and power is the multiplication of voltage and current, right? And the unit was watt. But here you will see in AC circuit, there are three types of power. One thing that you learned, multiplication of voltage and current, but then we will be multiplying by another factor, cosine of theta, which is called power factor. So this is called real power. And then voltage multiplied by current multiplied by sine theta. This is called reactive power. And simply the multiplication of voltage and current, we will call it apparent power. So in AC circuit, there will be three types of power. So this is a little bit complicated than DC circuit. So but you will be fine. You just need to follow my class notes and class lectures. I will be discussing numerical problems. You will be asking questions. I will be answering. And then over the time, you all will be fine. Okay, then next we will be discussing circuit analysis in the S domain. S means Laplace domain. So I believe in signals and system course you will be learning. Also in any math course, you might have learned that Laplace. So because this course will involve frequency of the waveform, but frequency makes the analysis complicated. That's why we will take the help of the Laplace, and that will make the calculation easy, just like the simple algebra. And then the number one, the most important topic among all the chapters in this course, that is the frequency response. So you all know that the frequency of United States is 60 Hertz. But if you change the frequency, like 62 Hertz or 52 Hertz or much higher frequency or much lower frequency, that has dramatic impact, that has severe impact on the system response. So that's why frequency response is very important. So you know about the filter. So there are several types of filter, and just by changing the frequency, the filter's response can be changed. And then magnetically coupled circuits, like you have one coil and you have other coil, and there is no direct connection between those two coils, but still from the left side coil, power can be generated on the right side coil. Or if you apply power on the right side coil, power will be developed in the left side coil. And there is no direct connection. They are just magnetically connected. That's why the chapter goes magnetically coupled circuits. So one simple example is the transformer. And we will be covering in the class, then you will be fine. And then two-port networks. So far you have learned that is the single port network, the DC circuit, even AC circuit single port, but that magnetically coupled circuit, that is one good example of two-port networks. This means you have one input output, and then again you might have another set of input and output in the same circuit. Accordingly, the name goes two-port network. So we will be looking how the one set of input and output is related to the another set of input and output, and so on. Then Fourier circuit analysis. You will also learning this Fourier circuit analysis in the signals and system course, as well as in any of the math courses. This is basically, for example, you have learned DC and you will be learning AC. And as I said in the second bullet, sinusoidal steady state. This means AC waveform look like the sine wave. But for example, it does not look like pure sine wave. Somehow there is noise and oscillation and signal got distorted. Or you want to apply that DC, but that DC has some offset, some sort of disturbance. In that case, you cannot analyze the circuit easily. So you have to take the help of Fourier circuit. So this means Fourier circuit means a signal can be decomposed into many components. So there can be DC component, there can be sine component, there can be cosine component, there can be 60 Hertz frequency, and then higher order frequency. So the goal of the Fourier circuit analysis to pick up, to find out only the 60 Hertz signals, which is called the fundamental frequency. So we will be looking how we can do that. And then the last bullet is polyphase circuits. So typically, in AC circuit, you will be learning first single phase and then the 3-phase. But there are 4-phase, 6-phase system. But we will be concentrating only 2-phase system on its single phase and on its 3-phase system. So that's why it is called the polyphase circuit. Okay. Now here is that grading policy. Homework, I think so I have written this wrong. Homework is 20% and then project will be 10%. So I will correct this slide. So everybody, you remember, homework will be 20% and then project will be 10%. And midterm exam will be 25%. Final exam will be 20%. Lab will be 25%. So I will change this one. And then grading scale, this is pretty standard for the university. But, I have written, however, the instructor reserves the right to adjust the scale if needed. So we will be discussing these things later. So once you will be submitting me the homework and you will be facing the first midterm exam, and we will be discussing again about this. And then had some, standard notes, like at least 90% class attendance is needed. If you can't attend the class for some reasons, please let me know about it in advance. Even though remotely, please let me know that, hey, the next class I can't join. This is the reason. And you must submit your assigned homeworks and others within due date. Exam format will be announced before each exam. And please work independently on homework, exams, and projects. Let me share another document. Just a moment. Now I'm stopping share this one. Let's start another document. Everybody, can you see this document PDF file? Yes. Okay. So, this is the document that I uploaded and emailed you last week, the syllabus and then class schedule. So you all got. And then, that here I have written, if the university decides to go hybrid, then we will be going back to class. But then again, because this will be hybrid, in each class, everybody does not need to go to the class. What will happen, for example, on Monday, maybe I will allow 10 students in the class, and then remaining 20 will join remotely, through Zoom. And then in Wednesday, another 10, and then remaining 20 will join remotely. Same thing for Friday, another 9 or 10, and then remaining will join remotely. So I will figure it out, who will be coming on Monday, who will be Wednesday, who will be on Friday. This means even though the university might go on hybrid, but you would need to come to the physical class only 1 day per week. So you will be fine. And then if the university does not decide to go with the hybrid, then fine, as usual, we will be going through Zoom video that we are doing. Okay, and then you see here are the, today it was like August 17 introductory class, but then from next class, we will be starting that RLC circuit, like source-free parallel RLC circuit. And as I told you that I think I uploaded up to class 9, the class lecture material, but today I will be adding my audio voice. So, I mean, I will be adding my voice slide by slide on the PPT audio. So one by one, you will be clicking and then you can listen to my voice, or you yourself might be able to understand. And then once you will come to the class, I mean, Wednesday, then you might have questions, comments that you'll be doing. But I will be going over the material once again, so then it will be clear. And then that time I will make a recording of it. Any questions, any numerical problems, everything will be recorded. And I will be uploading that video on the eCoursera. So you'll be fine. Okay, so here you see, as you can see everybody, I have scheduled your first midterm exam on September 21st. So therefore, at this point, you are fine. You just keep going with the class. You follow my class. I will be assigning the homework. Before that, at least there will be 2 to 3 sets of homework. After 2 class, I will be assigning you the homework you solve, and then 2 classes before, I will be discussing with you about the question pattern. So you will be fine. At this point, you just look the syllabus. And then second midterm exam is scheduled on October 21st. Okay, so here is the thing. You see, although I mentioned this is the exam time, you mean this class time, but because you will be doing remotely, so we will allow you some time before and after, so you will be fine. So at this point, you just be relaxed. I will be discussing before the exam, so you will be fully fine. And then midterm exam 3, November 11th. So you see, although I said there will be 2 midterm exam, I was showing you the PowerPoint file, but I will be taking 3 midterm exam. And what I will be doing, I will be picking up your base 2 exam. For example, you got 100 in one, you got 90, and you got 80. So I'll be canceling the 80, the lowest one. So I'll be picking up your base 2. Or you got, for example, 80, you got 70, you got 60. Just an example. So I will cancel your lowest one. So then the goal is that by having 3 exams, you are covering the whole syllabus. You will be learning a lot. On the other hand, I will be canceling your the lowest one. So then you will get benefit in terms of the grading. And then the final exam, November 20. So keep in mind the final exam time is different than the class time. Final exam is from 10:30 a.m., not 9:10. This is the university suggested time that I have followed here. So again, I will provide you the instructions, so you will be fully fine. So at this point, everybody please just be relaxed. And the class project presentation. So I am showing you the another slide. So this due date, November 13, November 16. So I have not yet assigned who will be presenting on November 13 and who will be presenting on November 16. But soon I will be assigning that and I will let you know. But let me go to that slide. So let me stop this one. And again, let me share. Okay. Everybody, can you see this slide, class projects?
Yeah.
Okay. So as you can see, there are 10 projects I have selected. First of all, so as you can see, first on like automated external defibrillator, it is called AED. Second one is electrocardiogram, EKG or ECG. So I think you all know these all are the biomedical or the medical device. But all these devices include the circuit that you will be learning in this class. That is the reason I have assigned that if you can simulate, if you can build these circuits, then that's great. So what you have to do by each of these products, you will just be simply simulating. So you all know PSpice, right? Do you know PSpice?
Yeah.
Yes.
sir.
Okay, or I believe you also know the MATLAB, right? MATLAB?
Correct. Yes, sir.
Okay, so the whatever, I mean, there is no restriction, either you use MATLAB or PSpice. Your task is you will be simulating these circuits and you will be showing me the result. Okay, this is working, that's all. That thing you have to present on the scheduled presentation day. And you will be returning me your presentation slide. So there is no range of presentation slide. You might prepare only 5, you might need 10 for better presentations. Okay. So, and then I have put your name like first on Priscilla, Eric, and Griffin. So in that way you can see your name. So you have, in this class, we have total 29 students. So therefore the last one, only 2 students, automobile ignition. So therefore you need not to be worried, like from 1 to 8, all are the important medical or the biomedical device, and that involves circuit. And those circuit, either RLC series circuit or RLC parallel circuit, simply RL circuit, or operational amplifier, or some sort of filter. So as the days goes, you will be learning the subject matter of this course, then you will be fine. You can simulate. So at this point, everybody please feel relaxed. I mean, don't worry. So you will be fully fine. I will be explaining you over the time. Just one more thing. Let me once again. I'll be showing you through something white. Can you see the whiteboard, everybody?
Yes.
Okay. So just I will showing you a little bit thing. Okay, and then, okay. Can you see the drawing that I'm doing? Yes.
Yes.
Just okay. Okay, so let me first draw and then I am telling you what I am doing. Okay, noted. Let me draw text. Okay, so I'm almost done a little bit. Okay. Okay, so just a moment. Okay, so everybody, can you see the leftmost component? I have written like, this is a picture of a generator. So it's called generation. Okay, what I am trying to show here, can you see that at the leftmost I have written generation, and this is generator and 11 kV. This means 11,000 volt. And at the last you see I have written customers 120 volt. So customers means like we are the customers. So at our house voltage is 120 volt, right? So you know that, right?
Yes.
Yes. So what I am trying to show here, that how you get power at your home. I mean, I want to show that what portions of the circuits we will be covering. So that is my intention with this whiteboard. So you see, assume that the here generation, at first 11,000 voltage is produced. But at our home, we get only 120 volt. And in between, you know, this is this symbol, like there are two coils. This is a transformer. Let me write. Sorry. So this symbol, this is the transformer symbol. So first power plant produces 11,000 volt, and then transformer raises, boost of voltage 160 on kilovolt. And then you see this is the like resistance, inductance, resistance, inductance, resistance, inductance. These are called the transmission line. This means here the voltage is very high, at least 160 on kV. Even it might go like up to 1000 kV. You see, it might go up to 1000. So here at the transmission level. And then after that, there is another transformer. You see, so first there was on transformer, again there is transformer. And voltage is dropped down to 33 kV. And then again there is another transformer, voltage is dropped down to 11 kV. And again there is a small transformer. Finally, voltage is dropped down to what we need at our home. So this is kind of the flow, how we get power from a power plant to our home. Accordingly, I mean, you see, I have written sub-term like generation, transmission, distribution. So if you are asked the question as an engineer, especially as an electrical engineer, what is your main task? What is your main function? You would answer in that way. I will generate power. I will transmit it over long lines. I will distribute power to the customers. Do you understand what I am telling? Like, I will generate power, I will transmit, then I will distribute. Finally, I will provide power to the customers, which is on 20 volt. Now, you need not to be worried about this flow diagram, but what I am telling, you see, there is one component. This is the transformer. This transformer, you remember when I was discussing the course preview, This is the example of magnetically coupled circuits or two-port network. You see there is no direct connection, but still the voltage is transferred or power is transferred from left side to right side. And then there is resistance inductance. This is RL circuit. So you all know. So you see the direct application of circuits. And again, although I did not draw, but there is resistance inductance and regular intervals, there are capacitor involved. And from here to here, there are lots of controller, lots of communication system, lots of microprocessor based control. Everything is involved like from here to here. So therefore, the circuit that you have learned in case of DC and that we will be learning in this course, everything is like between from this point to this point. So, I mean, in other words, this is the main thing of the like electrical engineering from this point to this point, and your circuit course, signal analysis course, control course, everything is within this range or within this boundary. So let me save this one so I can. Okay, so I think today we are almost done. It's about like 10 a.m. So do you have any questions or comments? Do you understand this one?
Yes, sir.
Okay, so of course you can see this one because I made the video. So I'm going to upload right after the class. So in this way, like after each class, immediately I'll be uploading the video. So you can see the entire thing from the beginning, what we discussed in the class. Okay, so now I am stop sharing. Okay. Let me see on the chat. Do you have any question? What you can do, you can even type your question on the chat session. So I would be answering. I think there is no question. Okay, fine. So is everybody fine? So do you have any questions, comments, anything?
How's the project handled?
Okay. So therefore also once again, I think where is the project? Oh, okay, here is the project. Can you see the project slide?
Yes. Are they teams or individual projects?
No, this is the group project. For example, if you see the number 1, automated external defibrillator, like Priscilla, Eric, and Griffin. So your name is, what's your name? Who is talking?
Emma Rone. I'm sorry, my mic wasn't working earlier.
Okay, yeah. Where is your name?
I'm on number 8.
Okay, yeah. Okay, yes. So for example, insulin pump. So it's a group project. So what you can do, I have sent you an email. I think twice I have sent email. So in the email, you can know what is the email address of Khalib and Rajik. So you all three need to coordinate, and you will be finding. You can Google the insulin pump circuit, and then circuit will pop up. You need to just simulate that on either using PSpice or the MATLAB. And first you will be understanding how it works. You will be learning the working principle, how that circuit functions, and then you just prove that through simulation. So on the presentation day, all three of you, for example, probably you will be allowed 10 minutes to present. So that, I mean, it's kind of the 3 minutes or 4 minutes. So it's a group project. So is this fine?
Yes, I understand now. Thank you.
Yeah, okay. So therefore, over the time, I mean, you may not start right now, but like few classes, let me first cover a couple of the things. First 2 things, number 1 and number 2, these 2 topics, I think number 1 is at the end of chapter 8 of the book, and chapter 9 of the book, and number 2 probably at the end of chapter 6 or chapter 7. You can see these 2 are available in the book. But the rest, like I have set up, but all are also related to the subject matters of this course. So basically, this is the circuit. You need to understand how the circuit works, and you just simulate. Then you'll be fine. And you know, all are the medical components. So you will be learning a lot. Yes, and these are very vital in the job market. Sometimes you would be asked, okay, have you done any project? So yes, I have done. What's your project? For example, my project was insulin pump. So that's great. So therefore, all are the very hot topic. Like number 9, wireless electric vehicle charging. Like you have a car and you want to charge, and then it is wirelessly. So what is the circuit and how you can simulate it? So automobile, again, the car ignition coil, spark plug. So there is a circuit. How you can represent? So again, like number 9 is the application of 2-port networks, magnetically coupled circuits. Number 10 is the application of RL circuit that you already have learned in DC circuit. In that way, in fact, all are the applications of circuits. So accordingly, I have set up the projects for you, and these all are the very hot. And I believe you all will be learning a lot by doing these projects. So you don't need to make any hardware, just the software. Just either you use PSPice or MATLAB or any other software you feel comfortable, and just show me the result on the presentation day. That's all. Okay. Is there any other questions, comments from anybody?
Yes, I have one. Are we meeting for lab this week?
And no. I think from the second week.
Second week, okay.
Okay, so I think Dr. Farooq Ahmed has already posted syllabus in the lab component. Have you seen that syllabus? I'm talking about the lab section.
Yes, it's posted already.
Yeah, it's up there.
Yeah. So, I mean, before I discussed with him, as we discussed, I think lab will start from from next week. Yeah. Next week. I think this week, you don't need to go to the lab. So, any other questions, comments? Okay, if no, then thank you everybody for joining the class. So see you on Wednesday. Today I'm going to add my audio voice on the class lecture 2. I mean, today I did not add because you can see this is basically the introductory class. But today I'm going to add my voice in the class lecture 2. And you need to go to the eCourseware and you see, you might not need to listen to my voice. If you yourself understands by looking the slides, that is fine, but not then listen to my voice. But again, you might have question, comments, of course, I believe. Then I will be covering in the class. I will be answering your question. I will be discussing numerical problems. So then everything will be fine. In that way, we will be going. Okay, so with that, thank you everybody. So see you on Wednesday.
Nice to meet
Okay, thanks.
you, Dr.